Hello, friends. This is Jim with Science Talk. I have, you notice there's a little graph up here. I want to discuss what we're looking at here. And basically, this goes back to a report that covers the time period up till this past April. And that April was the 400th straight hotter than average month. That means 400 months in a row, the temperatures have been hotter than the average. NOAA, National Oceanic and Atmospheric Administration, announced this milestone, if you can call it that, recently, confirming that we are definitely living on a warming planet. The governmental agency notes that while another warming milestone has been reached, the signs have been clear for decades. Professors, government scientists, independent agencies, industry scientists all use the 20th century average as the benchmark from which they compare today's temperatures. This ensures people around the world are using the same temperatures as a baseline. While there is cyclicity in climate and hence average global temperatures, the consistent and prolonged degree to which Earth has been on the hottest spectrum makes it clear that there are external factors at play. When comparing long-term historical records, it is clear there is a warming trend. Now, I will be preparing for you some videos where I'll discuss some of these cyclicities in the climate. Talking about the Milankovitch cycles. We'll talk about the role of ENSO, which is the El Nino Southern Oscillation cycle. I'll talk about the Pacific Decadal Oscillation, or the PDO. I'll talk about the NAO, the North Atlantic Oscillation, sometimes called the AO, the Atlantic Oscillation. I'll talk about what all of those do, the effects of it, the periodicity of those things, and then tie it in to what is currently happening. Again, I go back to what I always stress, the rate of change. Now, if one were to look at the Milankovitch cycle, according to the Milankovitch cycles, Earth should be entering a cooling phase, and we're warming up. So it's almost going in the opposite direction. So that actually makes it easier to tease out the Milankovitch component of the signal, whereas if Milankovitch predicted we're warming and we're warming, then it gets a little harder to say, okay, how much is due to Milankovitch and how much is due to human activity? So if it were that case, we'd probably be a hotter planet based on what we're doing. So from a statistical point of view, Milankovitch predicting a warmer climate makes it harder to tease out the signal. Think back to my regression videos where I talk about how much of the variation in the response can be attributed to whatever the independent variable is. But things are happening. So what are we looking at here? Okay. We'll notice that on the bottom here, okay, we got 1950, 60, 70, 1980, 1990, 2000, 2010, and projection up to 2020. The red squares indicate land surface air temperatures. The blue squares indicate sea surface water temperature, or something that's called SST, sea surface temperature. And the land lowest smoothing and the sea lowest smoothing. That's basically, think of it as a regression-like analysis, more of a Fourier aspect to here. I don't want to get into that, called Fourier smoothing process. But basically, they're fitting a function with the data points. Now, you notice if you look at the sea surface and the land surface, we got these little flags here. Okay. They're connecting the dots, but basically It doesn't really show. They're pretty much connecting the dots through these points here. It would have been too cluttered to show the error associated with each data point. But as I said before, when typically fitting some sort of a function through data points, the curve will go through at least the interval determined by the error for each data point. So if I had, let's look at this point here since it's easily visible. If I had error flag, might take it up to here or down to here, and as you can see, the curve will fit within that prescribed interval. So this 0 here is that baseline, the average 20th century temperature I referred to earlier. So if you're at 0, that means there's no deviation from the average. If you go below 0, you are cooler than the average. If you go above 0, you are warmer than the average. That's what's meant by the vertical scale here, temperature anomaly. As you can see, it goes from 0 to 1.5. This is in C. So as you can see, if you look at the land and the sea, they pretty much track close together into about the mid 1980s or so, up to maybe late, like something like 87, what have you. And then what do we see going on here? Bang, the land temperatures start increasing rather dramatically. The sea temperatures are still increasing. And remember, water has a higher specific heat content. It takes considerably more energy to heat up the same volume of water as it does to heat up the same volume of air. So the fact that the water temperature is still increasing is testament to how much energy water has absorbed. Really warm. I mean, look at this. This goes up to base. This is April right here. And if you read across, that's approximately 0.6 of 1 degree Celsius above the average from 20th century. Look at the land here. That's about 1.3 or so. And we're trying to do what? We're trying to keep according to the Paris Accord, we're trying to keep it to 1.52 degrees warming. We're almost at 1.5. Look at that. We don't have much time. The IPCC recently issued a report saying, yeah, we need to cut all emissions of greenhouse gases to 0 by 2050, to considerably less by 2030. And if we don't do anything by 2030, we're basically screwed. And 2030 is now, at this point, just a little over 11 years away. Not looking good for humans. Governmental agencies have all agreed the warming trend seen in recent decades is mainly due to humans emitting greenhouse gases such as carbon dioxide, methane, hydrofluorocarbons, even water vapor acts like a greenhouse gas. And of course, these gases behave like a blanket trapping heat. I mean, all you have to do is take an aquarium, just a basic aquarium. Stick a heat lamp in there. Stick a thermometer in there. Have it uncovered. Record the temperature. Then cover the top of it with a blanket and watch what happens to the temperature. Doesn't even have to be a heavy blanket. Doesn't even like a comfort or anything like that. Even throw a towel over there. Watch what happens. Europe has just had its warmest April in recorded history. We saw extreme heat waves with southern Pakistan reaching 122.4 degrees Fahrenheit on April 30th. Looking at the other side of the same coin, carbon dioxide levels just reached 410 parts per million, higher than it has been in the past 800,000 years. I just saw a recent report where they're now saying that this might be the highest the CO2 levels of the past 15 million years. However, and looking through the data and the analysis, the error is considerable. So to me, it's not settled. Right? I did an earlier video where I explained that the issue of the errors and so on and so forth, it still applies here. So I am not yet convinced, but to say that it's the warmest it's been in the past 800,000 years, the evidence for that is very, very solid. As temperatures continue to rise, they do so disproportionately in higher latitudes. Translation: the Arctic is the fastest warming region on the planet. So we've seen significantly more warming in the Arctic and Antarctica than in the tropics. This leads to more ice melting, higher sea levels there. So here are some of the manners in which a changing climate will impact humans indirectly. Many animals and plants require specific temperature ranges to survive. So temperatures change, plants a little harder for them to migrate, but the animals will certainly be migrating. This includes fish. Species of fish have preferred temperature ranges. And if a fish ends up in too warm of a water, it accelerates its metabolism and has to eat more, and it may actually burn itself out metabolically. So fish will move to preferred cooler temperatures. Also, as I just discussed in a previous video, warmer waters means less dissolved gases. A little harder for the fish to respire. Humans rely on consistent weather patterns to know where to grow crops and where to live. A changing climate and disproportional high latitude warming will change rainfall patterns. That can lead to multi-year droughts in populated areas, floods in previously dry regions, lack of rain in once fertile farmland. In other words, everything gets all jumbled up, and you can't predict what's going to happen. Warmer high latitudes melt ice, sea levels will rise, of course. This will exacerbate flooding in low-lying coastal areas. And if there are storms, no sea ice, the coastlines are exposed to battering, and you could lose chunks of real estate into the ocean. This is the case for a lot of, for example, up in the northwest portion of Alaska, some of the villages have had to relocate due to the land literally eroding out from under them. In the case for a warming planet, the past is the key to the future, to understanding what is coming down the pipe. By all accounts, the planet will continue to change at unprecedented rates, back to that rate of change. So I wanted to bring you, this graph. This is a very telling graph. This is an important graph, showing you the warming trend clearly for both air and sea. This is just, this is data. So anyone tells you it's all made up stuff, you can just show them this graph and tell them to, well, whatever. So thank you for your time. We'll talk soon. Hello, folks. This is Jim asking for your help. I want to grow this channel significantly. I want to increase the number of people who subscribe to my channel. I want to increase the number of people who are supporting patrons on Patreon for this channel. Patreon.com/Science Talk with Jim Massa. I do not receive funding of any sort from anyone. So the information I share with you is the information as found published in the peer-reviewed journals. No propaganda, no BS, just the science, and of course I give you my interpretations and analyses based on my experience as a scientist. So please tell others of the work I do here, tell others of my channel. Share my videos, post them on other social media platforms. But we need to disseminate this information to more and more people, to a wider audience. And I need your help in doing that. For those of you who are already patrons and support me on Patreon, thank you. Thank you for your support and continued support. Together we can do this. So you'll find details in the description box below, how to support me on Patreon. And thank you. Thank you for your help. Thank you for your continued support. It does mean a lot to me. We can do this.